Hey guys, it's Jen Gately here with another AP Bio walkthrough. Coming to you today from this cave because we are looking at this question about blind cavefish. This question is number 4 on the AP Test 2, the practice AP test available through the Princeton Review Premium Prep edition that has 2 online tests available. This is from the 2021 edition. Looks like this. Got a cute little chimpanzee on it. All right, so we're doing test 4 or number 4 from test A. This is the second short answer for your response question. Okay, so we did some calculations before about how long they should take you. You can check that out in another video. Each short answer is going to take you typically 11 minutes. All right, so that means we have enough time to not be rushing through the question, right? Because reading and understanding the question is the most important part. I've said again and again, the AP Bio test is a reading comprehension test, okay? So let's go ahead and get started. After millions of years living in darkness, a species of blind cavefish has lost an ancient system of DNA repair in most members of the species. Okay, changes over time. That DNA repair system found in organisms including bacteria, fungi, plants, and most other animals harnesses energy from visible light to repair DNA damage induced by ultraviolet light. Okay, let's stop right there because these are blind cavefish we're talking about, right? Are they getting a lot of exposure to visible light or ultraviolet light? No, because they are blind cavefish living in a cave where no sunlight gets to. Okay, just something to keep in mind as you keep reading. Only placental mammals were previously known to lack this system. Interesting. This system was found to be turned off in 84% of the population of the blind cavefish. They gave me data, so I'm probably going to be doing a calculation. Okay, let that be a clue to you. The only way to have the DNA repair system turned off is to have 2 recessive alleles for the protein that turns on the system. What is that going to look like? You could do something like this, right? Double A, okay? So you can say double A equals 84% of the population, okay? So the only way to have the DNA repair system turned off is to have those 2 recessive alleles, okay? If you want to take another moment, right? Pause, read this through again. If you're not quite understanding everything, feel free to do that. What is happening, just as a recap, is we've got this lost DNA repair system, okay? Why might it have been lost in these cavefish? Because it's really kind of unnecessary. So probably something, a mutation perhaps, maybe some kind of selection caused this DNA repair system to be turned off with really no negative effects. Because again, they are not needing to repair damages caused by ultraviolet light because they live in a cave. Okay, so let's jump in to number A, letter A. If there are 2,000 blind cavefish in a population, identify how many individuals are heterozygous for the gene that turns on the DNA repair system if the population is assumed to be in Hardy-Weinberg equilibrium. It's heterozygous for whatever turns it on, okay? That means it's not going to be AA. It's going to look something like this, right? And this dominant allele is going to be what turns the system on, okay? So both heterozygous and homozygous are found in 16% of the population, right? Because 84 plus 16 equals 100, okay? And so we don't really know yet how many individuals or even percentage the heterozygous or the dominant homozygous is, okay? So how in the world do we find this out? Well, they give us a little clue. They want us to think about the Hardy-Weinberg equilibrium, okay? Hardy-Weinberg is the P and Q one, all right? So it goes like this. The equation for Hardy-Weinberg is P squared plus 2PQ plus Q squared equals 1. Okay, P squared plus 2PQ plus Q squared equals 1. Okay, so we need to remember when we write this down that Q is going to be the recessive, okay? Q is always the recessive. Here, I'll do a different color so we can really see it. I'll do blue. Okay, so this represents the frequency of recessive. This is the frequency of heterozygous dominant. And this is the frequency of homozygous dominant. Okay, so whenever you write down your Hardy-Weinberg equilibrium, go ahead and write these above it there too. Okay, something else that is useful to know is that if you simplify this equation, what you get is P plus Q equals 1. What in the world does this mean? This is one version of the allele, okay? P is the dominant and Q, right, is the recessive. And so what they're saying here is that these two alleles, right, the dominant and recessive forms of this gene make up 100%, that's what that 1 means there, of all of the whole population, okay, in the context of that trait. So that's really useful to know. Okay, so let's kind of keep that there for now. Now they want to know, let's go back to the question and make sure we know what they are asking. How many individuals are heterozygous for the gene that turns on the DNA repair system? So they want to know, can you find it? Right here. But what this is going to give us, guys, is a percentage. Okay, just like we already know what your recessive is, your recessive percentage, it's 84%, right? Okay, and you got to write that like this in this equation, 0.84. This is going to be some percentage, okay, that we will write as a decimal. Okay. Okay, so they want to find that out. How in the world are we going to do that? We don't even know P. Well, wait a minute. We can find out P pretty easily, right? Because all we have to do is plug in for this equation over here, right? You might say, well, we don't really know Q yet because we only know Q squared. You can easily solve that by taking the square root of 0.84, which is where that 0.92 came from. When I originally did this calculation, I put 0.91. It is actually 0.916. They want you, I think, to go ahead and round up to 2, although they are really flexible about rounding. And as we'll see in a second when we check out the answer, they will actually accept a range of values. Okay, so don't be freaking out that you need to get the exact right value. They just want to see that you can follow through, right? Follow the chain of logic that is required to reach the answer, okay? So anyway, we got to take, here, let me erase this. SNP is a little bit harder to use than I would like, but basically you're going to take 0.84 over here, square root it, okay? And then you have your P plus that is going to equal 1. Okay, so what's the square root of 0.84? It is 0.92 equals 1. Then you can say 1 minus 0.92. And what do you get for P? P, let me scroll up a little bit. Can I do that here? P equals 0.08. Okay, so we've got P. We know what P is now. Great. Okay, so we can plug in to this other equation over here. All right, so you can pause this and kind of copy what I've done because I'm about to erase it. All right. All right, now it might be tempting to plug this in over here. Square it, go through, and plug in your values for P and Q, okay, and then solve it. But guess what? You actually don't need to do that, okay? Because all you really need to do is plug P and Q into here, right? Because that's the one they want. They want the heterozygous. All right, so let's forget all this stuff. And all you got to do is do 2 times P. What was P? 0.08. and multiply by Q. So here it is, 2 times 0.08 times 0.92. Okay. Okay, so easy calculation. 0.08 times 0.92. All right, now we have to multiply that by 2. Oh gosh. This is 0.0736. Multiply that by 2, and you get 0.1472. All right, so what in the world does this mean? Well, this is your percentage frequency, right? So another way you could write this is 14.72%, but that's not what we're doing here. What we need to do next is find out how much, how many individuals 14.72% is out of 20,000 blind cavefish, right? So how do we do that? We multiply 20,000 times 0.1472. And that gets us 2,944 individual cavefish. Okay, this is not a percentage, and that's what they asked for, individuals. Okay, so that is how you do this first one. Let me hop over and show you the explanation, okay, that they give in the biology prep. All right, answers. Here we go. Okay, so they did the same thing we did. All right, heterozygous frequency is 2pq. They have 0.1472 times 20,000 right here. Okay, and then that's the same number that we got. But check out what they have. They will actually take, a range. Okay, see right there. And for some reason, this isn't working very well, but that's okay. So they'll take anywhere from 2604 to 3276. Okay, so if you are not sure about rounding, just do the best you can, because even if you took that 0.916 instead of rounding up to 0.92, you would still get an answer in that range. All right. Okay.